Well, hello and welcome back to another video. So, as promised, now is the time to learn about coroutines. Well, coroutine is very good feature of Kotlin. It gives you immense advantages when you are making an API calls and doing some long calculations and stuff. So, basically, executing complex tasks, you should use coroutines. Now, first of all, what is coroutine? So let's take an example of threading. I assume that you know about threading. Uh, we can break our tasks into different threads to make it simultaneous. We can calculate simultaneous calculations. We can calculate many calculations simultaneously together by dividing them and doing them into different threads. So we can think about coroutines in similar way. We do not want to do many tasks in a single thread because in Android, uh, it sometimes freezes the UI of the applications, right? So, like suppose we are calling an API or we have to make a complex calculation that takes time to execute, but we don't want to want our users to wait until that calculation is complete. We don't want to freeze our application's UI basically, right? So to achieve all of this, we can use coroutines as it is much more efficient to use. And yes, but it is important not to get confused between coroutines and threads. They are both different. To make it easier, let me just write here. I'm gonna be posting this code on my GitHub, so I should write this 2 points here that makes coroutines different from the thread. First is coroutines executes within the thread, right? It does not create a different thread. It executes within the thread. So I would write coroutine executes inside the thread. Okay, and I would also want to share another point, which is coroutines are suspendable. Now, what the heck is suspendable? Uh, it means that we can stop coroutines while it is executing some calculation. We can stop coroutine anytime we want, and we can rerun it. We can continue it at any time we want. So I'll write coroutines are suspendable. I'm sorry for the spelling mistakes here. Executes, not exits, and coroutines are suspendable. Okay, so make sure about these 2 points, and yeah, we can now write our first coroutines. Uh, do not really stress about the coroutines. If you practice enough, you can get the points here. So anyway, let's get started. So first of all, we'll need to add dependencies of our coroutines to use coroutines inside our application. So I'm gonna paste a dependency right away. If you want this, I'm gonna be putting the link of this code into description, so you can get the link from there and just paste it inside your project Gradle file and sync the project. Okay, so the project build is finished, and now we can go to main activity. Now let's launch our first coroutine. By the way, there are different scopes that we can launch our coroutines in. So the simplest way for the first time, as we are launching it the coroutine for the first time, I'm just going to launch it in global scope. Sorry, global scope. Yeah, global scope dot launch, Now in global scope, what happens in global scope, this coroutine will live as long as our application lives, right? When we close our application from the background as well, this coroutine will be will be killed, will no longer be there. So in global scope, coroutine will create another thread to execute itself. So let's see how it is done. I'm gonna be logging the name of the thread inside coroutine and outside coroutine, and we will see that it creates another thread, right? So let me just log the uh, instead of on create, I'm gonna be writing um, thread dot current thread dot name, right? So it will give me the name of the current thread, and I'm just going to be taking a variable here of tag equals to main activity. Okay, and I'm gonna be logging the same thing outside the scope of this coroutine. So we can see the name of the thread inside coroutine and outside the coroutine. Obviously, in onCreate function, when we launch the application, and when onCreate function is called, it will launch on the main thread. So this log line should give us main thread, and this should give us something else as the global scope of coroutine creates launches itself in different thread. So for now, let's wait for the application to run, and I'll see you at the end. Okay, so application is launched, and as we can see in the logcat, for this line, for line 18, outside the coroutine scope, we have the thread name main, and inside the coroutine scope, we have default dispatcher worker 1. It can be different for you, it doesn't matter. What matters is that for both of the log, we get different different thread names, right? So now, remember I've talked about we can pause the coroutine at any time, and we can launch it anytime. So let me just show you an example of that. We can call, just like thread, we can call delay function here, and inside this coroutine, and we can just let's pause this coroutine for 2 seconds and I'll log this again. So just let me copy paste this, and what it will do, it will pause the coroutine execution for 2 seconds, and it will then launch this line of code, execute this line of code. So let's rerun the application and see how it does work. And as you can see, I assume you have seen that it launched these two coroutine, these two logs, and it waited for 2 seconds. As we can see here, it's 50 and it's 53. So it waited for 3 seconds, and then it executed this line of code. So this is how you can pause the delay the coroutine. Delay would be the right word, and I think this is it for this video. In the next video, we'll dig into coroutines more deeply. So let's just like if you like this video, just give it a like and subscribe to this channel. So whenever I post this video, the new video, you get the notification of it. So that's it for this video. I'll see you guys in the next video.